702.
The Naked Scientist.
Hello, we've got the Naked Scientist with us.
Yes, good afternoon.
People know that if they want to find out anything about anything, they can get in touch with Chris. Chris, let's listen to what Julius has to say.
Good afternoon. I have a question for the Naked Scientist. So, Dr. Chris, tell me, if indeed water and soap does cleanse the body, why is it then that the towel you wrap yourself with after a bath or a shower still gets dirty?
Interesting point. Well, there's a few things to bear in mind here. One is that what's the towel doing? Well, the towel is mildly abrasive. So having loosened up lots of soft skin and other muck you might not have rubbed off with the soap from the bath, the towel then scrapes off the dead skin with the muck attached. And so the towel does pick up bits of you when you dry yourself off. That's the first thing. Second thing, in some parts of the world, and Joburg is one of them, water is very hard. It contains a lot of dissolved calcium. When you use soap, you end up producing scum because the calcium reacts with the soap molecules and sticks them together so that they form this scummy layer on the water. And as you climb out of the bath, the scummy layer, which has also got some of the dirt clinging to it, is going to also then stick back onto you. So when you rub yourself off with the towel, some of that scummy layer is going to come off of you and onto the towel, and that will make the towel dirty as well. It was dirt that you took off, put into the water with the help of the soap, but then stuck back onto you when you got out of the bath. So I think both of those things are reasons why a towel from a clean bath or shower is still going to get a bit dirty every time you use it.
Okay, we've got another voice note for you.
Hi, Jane and Dr. Chris. I've noticed since beginning of January and up until now, there's been a huge number of small little beetles flying all over the house, all over in the cupboards, all over the small beetles, all over the house. What causes this influx of beetles?
Oh dear. Well, I don't know what they are, and probably someone who is listening and has seen a similar thing can put us on the right track and give us an identification for what these beetles are. But it sounds to me like you're on the right track in the sense that they seem to be attracted by various food sources. Beetles are just flying insects, and you're quite right, they lay eggs. Those eggs will hatch. They tend to lay eggs in places that are protected and close to a source of food. So a beetle that gets in, finds a nice environment, can thrive there and find a mate, will lay lots of eggs. And these insects, part of the way in which they operate is to lay huge numbers of eggs, because some of the eggs are going to die, some of the eggs are going to get eaten, some will hatch into younglings, young beetles and insects that will get eaten, some will make it. So they tend to have an explosive population where there's a really good environment to live in and lots of food, and it sounds like they found just the place. You can get rid of beetles because they're insects with insecticides. Make sure you get an insecticide spray that is safe for domestic use. But if you spray around one of these insecticide sprays, they have a range of ways of working, but they are safe for humans if you get the right ones, but they affect the nervous system of the insects in question, and they will just kill them dead. I actually had a situation where my wife got some flea spray for a dog from the vet, or got some environmental spray just in case the dog had brought fleas into the house, sprayed it round, and it killed everything because we came in the next day and all of the surfaces were covered in dead everything, because this stuff was obviously very, very good at getting on air currents and going up into all of the nooks and crannies in the house, and insects, including ones you didn't know were living in your house, then die and drop onto all the surfaces. But make sure you get something that's safe for humans to use, and don't put it near your fish tank. Do not put it near environments where there may be animals that you do want and don't want to harm. Don't put it near those. And you'll see there are stark warnings on the back of the things. Do not put this near your fish tank and so on, because there are various species that live in your fish tank that will not take kindly to these sorts of chemicals.
And there's a reason that they have those warnings. Let's bring in Shalati. Shalati knows what's happening with these beetles. Tell us, Shalati.
Hello, Jane, and hello, Dr. Chris. I suspect, I'm not too sure, depending on where he's based in Pretoria, in Heartsease, we've had an influx, and we'll start seeing them from last week, of the weasels and plant poppers that are eating the hyacinths in the dam. So they've fallen and they've munched everything from the dam and are now being attracted to any source of light. So that could be it. They look like little flies, but they're not flies.
Well, thank you for calling with that information, Shalati.
Bye.
Thank you. Cecil, you've been holding on for a bit. Go ahead.
Hi, Dr. Chris. I've got a sort of esoteric question. I want to know how much the internet weighs. And I was just thinking, if one takes the equation E equals mc squared to be true, which I do, C is a constant, and data, there has to be energy. It's either a 1 or a 0, so there's energy. Then you have to be able to work out the mass.
Hi, Cecil. You're on the right lines. And in fact, I was thinking about this question last week because someone else was saying, does my USB stick weigh more when I fill it up with music? And I said, well, yes, it does if you fill it up with heavy metal. Boom. But the bottom line is that you're right, that because data is basically a switch or a change in the state of the transistors, which are the small switches, the microscopic switches which are in the microchips. If you are changing their state, you must be pushing charge onto them or off of them. So if you took a memory device which has got everything in its on state and you pull all of them down to the ground state, you're actually pulling some charge off. So they're going to lose mass. Because electrons are charge and electrons do have mass. Therefore, if you remove electrons from something, then you must be altering the mass. But as other people have pointed out, that very often these storage devices are going to have a random assortment of noughts and ones. The transistors are going to be, some of them are going to be up, some of them are going to be down, and therefore there's no net change. When you reconfigure the instructions on there, all you're doing is flipping them, so you're using some energy to change them from one state to another, but there's no net change. So therefore, the first time or the last time you write data on and off of these things, and in certain configurations you might get a change in mass, but it's hard to measure because you'd probably need to measure more of these sorts of storage devices than there are in the entire world to measure the sort of scale of change that you would expect just from doing this on one device. So it's a hugely tiny number, if you excuse the sort of contradiction, that it is the difference in mass that you're going to see if you are going to see one. But exactly as you say, E equals mc squared, so energy is mass times the speed of light squared. If you change the state of some of these things and give them potential energy, there must be a corresponding change in mass. So yes, data must weigh something because you are pushing energy and therefore changing the potential of the storage devices. So in theory, the internet has mass, but it's extremely hard to put a figure on that and extremely hard to measure.
Let's stay along the esoteric lines. Apostle Paul Maseko says, please ask Dr. Chris, is heaven a spiritual or a physical place?
Well, no one's ever been there and come back. So we only have people's speculation for, well, I suppose it depends on what you do with your life and where you go and that kind of thing. Some people's definition of heaven is another thing. But most religions have at their centre some kind of view of life continuing. It's the life we're living at any one moment in time is a temporary thing, and it's a journey to somewhere else, whether that's an afterlife, whether that is reincarnation, as some religions believe. It's a range of different concepts, but we all seem to centre on some kind of persistence. And it's very interesting that the brain seems to have evolved. It doesn't matter which culture you talk to, it doesn't matter which language people speak, where they evolved those particular groups of humans on Earth way back in history. There are many of the same sorts of convergences on people regarding gods and afterlives and so on. And this suggests it must be a function of our brain, the way our brain works, the way our brains have evolved, the way they generate thought processes and consciousness and give us a view of the world. There must be something about that that leads us to want to have a belief or to embrace a belief in some kind of afterlife or some kind of onward continuation, or you going somewhere after your physical life is over. But it's very much a thing that's in our minds because different people regard heaven as different things, and so therefore the construct is different for each person, but the ability to have those beliefs appears to be common to all humans.
Different ways of getting there too. Let's listen to a few voice notes.
Good afternoon to the naked scientist. I've got a quick question for you. There's a term which is called cracking the seal when you're drinking alcohol. I think mainly when you're drinking beer. You can go like for 6 beers without needing to go to the bathroom. But then like once you go to the bathroom once and you crack the seal, you literally have to go to the bathroom like maybe after every half a beer as compared to initially when you only had to go after maybe 6 beers, for example. Like, how does that work?
What a brilliant question. We used to sort of take the rip out of each other at medical school
Could all
because
relate to it.
you'd refer to people as having peanut bladders and things if they needed to go before they'd had at least 6 pints. Those were the days. Probably there's a range of things going on here. One is that there is a dwell time for the liquid in your stomach. When you start drinking, it doesn't instantly enter into your circulation. It doesn't instantly, therefore, start to affect the dilution of your blood, the blood pressure, and therefore indices that the brain and the kidney can see and act on to start producing urine. Also, you make urine at the rate of about 1 milliliter per minute. So there's a lag between putting the fluids into your body, the fluids getting absorbed, the fluids then becoming urine, and then the bladder filling up, and then you feeling the urge to go. So I think part of this cracking the seal thing that's being highlighted here is that there is the lag because you don't instantly need the lube because you haven't immediately put all that liquid into your bladder. And then once you reach that point where they're saying you feel like you have to go fairly frequently, this is because your kidneys by then are at maximum urine producing capacity because you turn up and turn down the rate at which you reabsorb water in your kidneys to keep your concentration of your blood steady. And once your blood is at a dilute state, and once the kidneys are then saying maximum dilution, please, of the urine, which it does with a hormonal signal from the brain and elsewhere, then that translates into the maximum production rate for urine. So I think there's a range of things going on here. One is the lag it takes for the stuff to get in the first place, then the lag for the body to start responding to the fact that you've got high volume in your circulation and to start producing more dilute urine, and to then fill up the bladder so you feel the urge to go. And then after that, you've got a steady, what you're putting in is almost coming out at the same rate, which is why you then feel the urge to start going more regularly. If you drink too much, you'll definitely go without even having to think about it, and that can be very embarrassing. So don't go there.
Don't go there. Here's a question about lions.
Dear Dr. Chris, this is Patrick. I'm just interested to know, like, how do male lion are able to see the cubs which are not theirs? I saw, like, in some of the programs that they actually kill them. Because as human beings, we use DNA to identify our own babies, our own children. But lion can just know and see it that these are not my cubs and kill them.
I think this is a brilliant question, and I think it's almost certainly down to something like smell. I don't know about lions specifically, but given how much ability and prominence felines place on their noses and their ability to smell, just like dogs, I strongly suspect that they do it by smelling. And here's an interesting experiment in terms of what you've been describing. If you take 2 mice and their brother and sister, and you put them in an enclosure together, and so they have no option, really, but to mate together, they will grudgingly mate together because they know that they're related. If you then introduce another mouse to this tank, say another male mouse, the female mouse can abort the pups that she's carrying grudgingly with her brother, and she will mate in preference with the male that she's unrelated to and start new pup family with them, because the animals inherently know that you're genetically better off if you have sex and reproduce with an individual who is genetically as different to you as possible, because this introduces the greatest degree of genetic diversity, which makes you more resilient in the long term as a population. So that's what you want. Now, how do the mice tell one mouse that they're related to from another mouse they're unrelated to? The theory goes that if you look in the mouse genome, there is a section of the genome that encodes what are called MUPs, mouse urinary proteins. These are found inherited alongside the genes that control your immune system and how your immune system works, and therefore they're a good marker for how genetically diverse you are. The urinary proteins are strongly smelled, and mice can pick them up. So if a mouse pees out somewhere and another mouse comes and smells it, they can get almost like a barcode of how genetically different this mouse is to me. And then you know whether they're friend or foe, family, unrelated, good mate choice, bad mate choice. So this is going on for animals like mice. It's probably also, you've got something similar going on. Animals can use this sort of smell marker for how genetically related you are with other animals. And is there evidence this happens in humans? Well, there might be, because people have done studies looking at populations who tend to breed within their population. So there are certain, say, religious and cultural groups, for example, who tend to marry in that group. Now, if you look at how big the population is, you can make predictions about how likely someone is, if they're just picking a mate at random, to marry someone who's closely related to them versus someone who's more unrelated to them. If you do this and you look at these different populations, you find that people on average are getting together with people who are more genetically different to them than you would predict on the basis of just chance. So it suggests that we too seem to be able to, probably through a range of different cues, but smell almost certainly is part of that, can tell people who are not related to us, and therefore we avoid fancying them. We don't know why we don't fancy them, but we know we don't fancy them because they're more closely related to us, and that probably has an influence on our choices as well.
But sometimes that goes wrong, right? I mean, there are quite a few stories of multiple donors and the sort of impact that's happening on societies.
Well, sperm donation's a little bit different from the situation I'm describing, which is people given free choice about who they want to marry. And in some societies, social factors can trump free choice, and so people are told who they should marry, or it's strongly impressed upon them that's who you should marry, rather than going with their gut instinct. And if you leave societies to choose on the basis of gut instinct to a greater or lesser extent, you tend to find people are going for people who are as dissimilar to them genetically as possible.
Okay, we've got another voice note. Let's listen to that.
Hi, 702. Dr. Chris, I'd like to know something. If the Earth suddenly had to stop rotating, would we feel that it has stopped, or is seeing that it's rotating at a very high speed, would we fall off?
Hello, mate. Well, the answer is you could do this experiment for yourself to a certain extent, because if you were to go onto a roundabout at a playground and spin it and jump aboard, and you're riding round, whirling round on the roundabout, and then get somebody to grab hold of it and stop it all of a sudden, you have inertia. Because the roundabout is spinning, you are spinning. And this means that you have momentum, angular momentum, round in a circle. And if you suddenly stop the roundabout, then the roundabout is no longer accelerating with you, but you've still got momentum. And unless you hold on very, very tight and can transfer all of that momentum to the stopped roundabout in a fraction of a second, which you can't, of course, you're going to go flying off. Another example is a motorcyclist who hits something, unfortunately. This happens a lot. Motorcyclists will run into something. Often a car pulls out in front of them and they go into the side of the car. What happens to the motorcyclist? The motorcycle itself stops, but the motorcyclist very often catapults over the top of the car because they're not fixed to the motorcycle. They are travelling with the motorcycle, they have momentum, but the motorcycle stops, they're not attached to it, they don't transfer their momentum to the car they've hit. Instead, they carry on because they have inertia. The same thing would happen if the planet suddenly stopped. Obviously, you'd have to explain why the planet would suddenly stop and you didn't. But if the planet did suddenly stop, you, with all that embodied momentum in your body, if you're at the equator, you're going around about 1,500 kilometres an hour, you would go flying off in a straight line away from the Earth's surface at the point at which the Earth stopped.
Gosh, I mean, that happened to a friend of mine recently, Chris, where she hit something on her bike and just carried on flying, and she's a rather injured person. And these things happen so quickly, don't they? Let's listen to another voice note.
Hi, Jane and Dr. Chris. It seems to me that while we're moving to a more green world going forward, that it makes sense to me for us to use hydrogen combustion engines. And it doesn't seem like, we need to change our current engines much, especially our diesel engines. You throw in some hydrogen in there, with a lot of air, burns up with the spark plug. The byproduct is water, so we're not putting all these fumes in the air and everything. Why is this not popular? Why aren't we using hydrogen combustion engines? Sabi, thank you.
A couple of things. One is that a fuel is only as environmentally friendly as its source and its products. Now, you've quite rightly pointed out that when hydrogen burns, it produces water because H2 plus O2 makes two molecules of water. for every molecule of hydrogen you burn, and that's going to come out the exhaust pipe as steam. It will, though, also make some nitrogen oxides, so it's not completely pollution-free. The burn temperature, the fact you've got a spark igniting it, you're going to have some nitrogen oxides, NOxes produced, so it's not perfect. But the big elephant in the room here is, where did you get the hydrogen? If you made the hydrogen completely from renewable green sources, so you had a solar panel which was collected up to an electric cell which was electrolyzing water, producing hydrogen, and you collected it, fine. That's purely green hydrogen. But we haven't got enough sources of hydrogen in the right places where we could do that at the moment. And so therefore there'll be a huge temptation to use hydrogen that comes from other sources, like you take methane that's coming out of the ground, natural gas, you strip off the hydrogen from it and use that. So hydrogen isn't necessarily a great saver of the planet if it's not translating into and sourced from a carbon negative or carbon neutral source. So there's that consideration. Then there's the infrastructure consideration. We've got 100 years plus of investment in a distribution network for petrol and diesel. We haven't got that for hydrogen yet. We've also got the transport problem. Cars would have to be adapted to have big cylinders of hydrogen so that they could carry the hydrogen around safely. We haven't got that yet. And so really we've begun to move into the electric car domain rather than think about the hydrogen domain. One has jumped past the other because people have tended to think, well, one might be a bit better than the other. But all of these things are worth considering, and they all have their place, and they are being used to a greater and lesser extent. There are trains that run on hydrogen, for example. There are some other machines that use hydrogen. Some cars can use hydrogen. So it's not a given that we're not doing this. It's that it's horses for courses, and that the infrastructure, which is very good at making sure wherever you go, you're going to find a petrol station or get some diesel somewhere. You can do that. At the moment, it's just not there for hydrogen, and there are those other considerations to take into account as well.
Chris, I'm going to let that big brain of yours take a bit of a break. Chris Smith, Chair of Science at University of Cambridge, thank you as always for your time.